Ever pondered over the origins of gold, that precious yellow metal we so admire and desire? Gold, in all its lustrous glory, has a backstory shrouded in mystery. This mystery is not of terrestrial origins, but rather, it's a tale spun in the farthest reaches of the cosmos. Yes, you heard it right. Gold is not native to our blue planet. The Earth, as rich and diverse as it is, could not have possibly produced gold within its terrestrial boundaries. The origin of this coveted element is nothing short of a cosmic phenomenon. This tale takes us beyond the confines of our own galaxy, into the fiery hearts of dying stars and the explosive grandeur of supernovas. There, in the cacophony of cosmic explosions and the silent ballet of celestial bodies, gold was born. Gold, as it turns out, is not of this world. It is a celestial gift, born from the stars. To understand the birth of gold, one must first comprehend the enormity of a cosmic event, the supernova. A supernova, in its simplest definition, is the explosive death of a star. It's a celestial event of such magnitude that it outshines an entire galaxy, making it one of the most energetic phenomena in the universe. But what triggers such a colossal explosion? In the heart of a star, nuclear fusion keeps it alive, converting hydrogen into helium and generating heat and light. As a star ages, it starts to fuse heavier and heavier elements until it eventually forms iron in its core. But iron is a celestial dead end. It consumes energy instead of releasing it, leading to an energy crisis within the star. Without the outward pressure generated by fusion to balance the inward pull of gravity, the core collapses under its own weight, triggering a supernova. In a fraction of a second, the collapsing core rebounds, sending a shockwave racing through the star's outer layers. This shockwave heats the star to incredible temperatures, causing it to shine billions of times brighter than our sun. The outer layers are blasted into space, leaving behind a dense, hot core. This core can become a neutron star, or if massive enough, a black hole. In the cataclysmic aftermath of the explosion, the expelled material, now a glowing nebula, expands and cools. It's in this cosmic forge, amidst temperatures and pressures unfathomable to us, that elements heavier than iron, including gold, are formed. Such is the violent and spectacular end of a star, an event that sets the stage for the creation of gold. In the next scene, we'll delve into the role of neutrons in this celestial alchemy. But for now, let's marvel at the awe-inspiring power of supernovas, the cosmic crucibles where elements are born. A key player in the formation of gold during a supernova is the humble neutron. Neutrons, despite being chargeless and almost massless, play an extraordinary role in the cosmic theater of a supernova. These tiny particles are the unsung heroes that enable the spectacular transformation of simpler elements into precious metals such as gold. When a star explodes in a supernova, it's not just a dazzling display of cosmic fireworks. It's also a cauldron of intense nuclear fusion, where lighter elements are forced together under unimaginable pressures and temperatures. In this crucible, neutrons are ejected en masse, and they start mingling with other elements in the star's core. Let's take a moment to appreciate the neutron's role in this alchemical process. You see, neutrons are like the glue that holds atomic nuclei together. Without them, protons would repel each other due to their similar charges, and the atomic nucleus would simply fall apart. In the heart of a supernova, neutrons interact with other elements, sticking to their nuclei and increasing their mass. This is where the magic happens. As the neutron count increases, elements undergo a process known as neutron capture. This process transforms lighter elements into heavier ones. It's a neutron party, and everyone's invited. Iron, nickel, and other elements greedily absorb these free neutrons, metamorphosing into precious metals like gold and platinum. But hold on, it's not just a one-way street. While neutrons are being captured, some of them decay into protons. This decay further adds to the atomic weight, nudging the element one step closer to becoming gold. It's a delicate dance of nuclear physics, a balancing act of creation and decay, all happening in the blink of a cosmic eye. And at the heart of it all are neutrons, the master craftsmen silently working in the background, shaping and molding elements into something more. In the chaotic aftermath of a supernova, these neutrons set about crafting something truly remarkable. In the heart of this cosmic furnace, amidst chaos and destruction, gold begins to form. As the supernova continues its spectacular display of celestial pyrotechnics, something fascinating happens deep within its core. Amidst the roiling chaos and the tumultuous forces at play, neutrons are launched at high speeds into atomic nuclei. This process, known as neutron bombardment, leads to the creation of heavier elements. The neutrons, being uncharged, can easily penetrate the nucleus of an atom. Once there, they can merge with a proton to form a neutron, thus creating a new element. This is the process of nucleosynthesis, where elements heavier than iron are formed. Now picture this. As the supernova rages, countless neutrons are shooting out, colliding and merging with atomic nuclei. As this cycle repeats, the atoms grow heavier and heavier, and then, almost as if by magic, one of the most coveted materials in the universe begins to form: gold. Gold, in its atomic form, is born from the violence and turmoil of a supernova. It's a fascinating process, really. The nuclei of lighter elements are bombarded by these high-speed neutrons, causing them to gain mass. As they continue to absorb neutrons, they transform, step by step, into the atomic structure of gold. This process of transformation, from lighter elements to gold, is a slow one. It requires just the right conditions and an immense amount of energy. But, in the heart of a supernova, these conditions are met perfectly. And so, in the midst of destruction and chaos, gold is formed. It's a beautiful paradox, isn't it? The birth of something so valuable from an event so devastating. It's a fine example of how the universe works in mysterious ways, creating beauty from destruction. From the ashes of a dead star, gold is born, a testament to the beauty that can arise from destruction. Born in the cosmos, this gold then embarks on a journey that ultimately leads it to us. You see, gold, once it's formed, doesn't just stay put. In the aftermath of the supernova, the intense explosion scatters the newly created elements, including gold, across the cosmos. This is a process known as cosmic dispersal. The particles, now traveling at incredible speeds, become a part of the interstellar medium, the cosmic soup that fills the spaces between the stars. Gold particles, now adrift in the vastness of space, can travel for millions or even billions of years. The cosmos is not a static place, it's dynamic and ever-changing. New stars are being born, old stars are dying, and galaxies are constantly moving. All these cosmic events create a complex network of gravitational forces that can alter the course of these tiny particles. Eventually, some of these particles find their way into the gravitational pull of a forming planet. For gold, this planet was Earth. As our planet formed roughly 4.5 billion years ago, it was a hot, molten mass. This allowed materials like gold to sink towards the planet's core. But don't worry, not all of it is locked away in the Earth's heart. Volcanic activity over billions of years has helped bring some of this gold back to the surface, where we can marvel at it today. So next time you hold a piece of gold, remember, it's more than just a precious metal. It's a piece of the cosmos, a testament to the power of stars, and a silent witness to the dynamic and ever-changing universe. Thus, gold, born of the stars, finds a new home on our planet. The story of gold's origin is a tale of cosmic proportions, quite literally. This precious metal we treasure so much has a birthplace that's far from ordinary. It's born in the violent, fiery throes of a supernova explosion. These stellar cataclysms, the death of massive stars, are in fact creators of life, spewing out elements like gold into the vast cosmos. The role of neutrons in this process is truly fascinating. These neutral particles, through a process known as neutron capture, fuse with other elements to create heavier ones, including gold. It's a process that takes place over 1 million years, proving that all that glitters is not only gold, but also time and patience. This gold then embarks on an epic journey, traveling across the cosmos, eventually finding a home on planets like our Earth. It's been here since our planet's infancy, buried deep within the Earth's crust, waiting to be discovered and adored by humans. So, the next time you marvel at a piece of gold, remember, you're holding a piece of the stars in your hand.